Let's face it, performance optimization is difficult. It takes a lot of effort, it takes a lot of time, and you're going to need to throw an expert or two at it. Okay, not physically toss your experts. They probably will not appreciate that. Yes, we all know that performance reigns supreme today, making performance tuning more important than ever before. No matter your optimization goals, it may be impossible or nearly impossible to manually investigate all of the configuration options, parameters, and layers of the software stack to get the optimization you need. But there is a solution that can help. Let me introduce you to Optimizer Studio, a full-stack optimization platform. Hi, I'm Amelia Dalton, host of Chalk Talk. Benchmarking is a great way to measure the performance of computing resources. But benchmark tuning can be a very complicated problem to solve. In this episode of Chalk Talk, Nozar Nozarian from Synopsys and I investigate Synopsys' Optimizer Studio that combines an evolution search algorithm with a powerful user interface that can help you quickly set up and run benchmarking experiments with much less time and effort. And before we get started, don't forget to click that link. There you can find even more information about this topic from Synopsys. Hi, Nozar. Thank you so much for joining me.
Hi, Amelia. Thank you for having me.
Absolutely. Okay, so we're talking about automated benchmark tuning today. But Nozar, before we get started, can you set the stage for us? What exactly is benchmarking?
So benchmark essentially measures the performance of a compute system. So when you put a system together, you're trying to understand and quantify how it will perform under certain conditions. What is the performance going to be when you put it through a certain workload? And what you need in the context of a benchmark is a methodology that you can repeat, right? You want to be able to do that measuring and that testing over and over in a way that's reliable and repeatable. And so those workloads, oftentimes they end up being workloads that simulate real life use cases. Ideally, that's what you want to measure and test. But in some cases also, you're testing the system at its limits. What would happen, for instance, if you were to throw a lot of data at an AI system? How would it handle it? So that's what you would do in that case. And speaking of those industry standard benchmarks, there's many of them available for various use cases. So I mentioned AI. There's, of course, specific benchmarks for storage, measuring the CPU performance, of course. And we see also benchmarks for in the mobile market as well. And those benchmarks are provided by communities and organizations that specialize in building those benchmarks. So the most famous names that you may have heard are SPEC, TPC, ML Commons. One thing I want to point out also is some companies really do a lot of benchmarking, right, as they release new products. And so you may have seen, some companies publishing their benchmarks.
So, Nozar, why is benchmarking so important?
Well, if you look around, right, in the world that we live in, you can see that every single device that we have now is now connected or has some sort of electronics going on. So one good example is, for instance, the car. If you look at 20 years ago, the car was very different than what you see today. Today, it's more of a computer on wheels, if you would. So what we see is that there's a need for performance, right? That happens. These devices get better and better every year. And this is very clearly driven by consumers, right? They want devices that are connected. They want their cars to be smarter. We're going towards having self-driving cars. And all that requires a lot of compute power. And so what that means is that tuning the system so that it's performing at its best, tuning that hardware so that you can extract the most performance is really critical. And benchmarking is essentially a way, as I mentioned, to measure how those systems perform. So, it's going to be critical in helping tune those systems. And that's why it's so important.
That makes sense. So, what would a tuning workflow look like? What kind of steps are we talking about here?
There's a few steps, and regardless of, I would say, the methodology or the tool sets that you use, you're going to find pretty much the same steps throughout that flow. So first, you need to prepare the benchmark. Essentially, you need to think about what is the workload that I'm going to test against, right? That I'm going to use to measure. The second step would be to choose parameters that you're trying to optimize against. Are you trying to minimize runtime for a specific application? Are you trying to maximize the throughput of your web server? Maybe you're trying to minimize power consumption. Or you're trying to do both, trying to maximize throughput or maximize performance while working within a certain power envelope. So these are going to be the goals that you're trying to achieve when you tune your system. And then the next step is to define what are the parameters that you're going to vary in your configuration. Essentially, what are the knobs that you're going to tune and to turn and play with. These are going to be depending on the system that you're trying to optimize. So it's going to be different from system to system. And you're going to have a list. It could be a several hundred that you're trying to modify at the same time, or you may want to focus on a dozen or less. But you're going to need to define what those are, the tunables, essentially. And then after that, you start with the first configuration, run it through your benchmark, and then measure that target parameter, that target metric that you're trying to optimize against. And then after looking at the output, you're going to decide to tweak some of the tunables, change some of the knobs for some of the parameters, and then you're going to have a new configuration. Then you run through the system, and you can see that there's a loop that you're going through. And this could take a while. It depends on your workload, benchmark specifically, how long it runs. Also, how far you want to go into your tuning, how many of those parameters, those tunables you're trying to adjust, right? If you have half a dozen, it's going to be probably much faster if you had a couple hundreds. But ultimately, you're going to report a set of results. And so what I want to highlight here is that this system, its methodology is a 6-step process here that I'm describing with a loop, but it seems very simple, right? I mean, in essence, it is, but actually doing that performance optimization is very, very difficult.
I can imagine. So, this makes me think that this kind of benchmark tuning would have some inherent challenges that we would need to tackle as engineers.
That's absolutely right. And as I mentioned, it's a complex problem to solve. And one reason is that if you look at the software stack that sits on top of the hardware, you have many layers, right? You have your compilers. You need to look at your OS that needs to be configured right. You may have BIOS configurations that you need to take into account. And then you get into the application level, right? Your web servers, your applications, essentially, that you're trying to optimize against. At each one of those layers, you have potentially hundreds, in some cases thousands, right? If you look at the compilers of individual parameters that can be changed. So if you start multiplying and all those possibilities, you end up with a solution space that is incredibly wide. There are so many different ways to configure each one of those systems, and that it's essentially it's impossible to do manually, even though that's the methodology that most teams end up adopting by default. And on the flip side, the other challenge is you have this huge effort to manually explore all those possibilities to try to optimize your system, but you have to do it really fast because your marketing team needs to get those scores for your benchmark out as soon as possible. And you need to put your best experts on the task that's really high effort and takes a lot of time to do. So this is really a challenge to get this type of analysis out within a given time frame.
That makes sense. Now, does Synopsys have anything to help me out here?
Fortunately, yes. So it's called the Optimizer Studio. It's essentially a full stack optimization platform. The idea is that we're able, through the software, to automate in a way that's smart. So you're using AI, the process of optimizing a system. And so when I'm saying optimizing, I'm saying that it applies to any of the software that's configurable within the software stack that you can see here. And it comes with a very nice user interface that allows you to explore the results of your experiments and your analysis, because that's a step that's very important as well, is being able to collect the data in a way that's consumable easily and share with your colleagues as well. And so if I take the example, the multi-step methodology that I presented earlier, you can see how this tool helps you. Essentially, where it is very powerful is that it automates the loop between choosing a configuration and running the benchmark. Essentially, at the end of the run, it's going to look at the parameters and using an advanced optimization algorithm, go back, select the right parameters and tweak them the right way before it runs that configuration again. And what this enables the tool to do is to really converge quickly on an optimized configuration. It's choosing the points to measure in the next configuration in a way that's very smart. And so you get that quick conversions into better results. And of course, it also comes with a library of tunables and a way to easily set any experiment. So the result is that you're going to obtain a configuration that will be more performant out of this system than if you were to do it manually, even as an expert. That's been our experience. But more than that, it's going to allow you to do that with zero effort, essentially. Once you run it, runs autonomously. It will shorten your experimentation cycles dramatically, going literally from months to days or weeks. So very powerful tool.
So, Nozar, do you have a real life example illustrating how this technology can be used?
Yes, and looking at benchmarking, we showed today the example of the SPEC-CPU benchmark. And so the experiment was actually pretty simple. So we decided to pick one of the benchmarks from the SPEC-CPU suite and see if we could optimize the compiler flags. In this example, we're using the video stream encoding benchmark running on bare metal. And the challenge was, can Optimizer beat the score that was published by a major vendor? Can we beat the experts at their own game?
That's great. So, how would you set up this experiment?
So what we did was look at the report that was provided and published, in this case by Dell, and we tried to replicate exactly the setup that they had in terms of hardware and software. And we looked at optimizing the compiler flags for the AOCC compiler. That's the AMD compiler. Now, I mentioned earlier that this tool Optimizer makes it very easy to set up experiments. In this case, it comes loaded with tunable libraries for the specific compiler. So setting up the experiments was, or at least importing those tunables was as easy as writing a one line of code that you can see here. Very, very easy. And so the starting point that we used to feed into the tool also was the configuration that was reported by Dell. And from there, we asked the tool to run the experiment and see if you could do better.
So, what was the outcome of the experiment, Nozar?
Well, it was pretty amazing. This tool, essentially, in a nutshell, was able to beat the experts' results by 7%. I think that's the way it was able to do it. That's the most impressive. In this case, we had an engineer that was not a compiler expert. He was not a CPU design engineer, and certainly not a SPEC-CPU expert. A few hours of work to set up the experiments and get it running. And then the tool is fully automated. So on its own, it was able to converge on results, as you can see here in the plot on the right-hand side. One aspect that's very unique about this tool, and it goes back to the advanced algorithm I mentioned earlier, is that it quickly converges on results. You can see in the graph, the starting point is that green dot. The first red dot is one of the optimal configurations that the tool found. And it's very quick in the way that it was able to find it. Only after an hour and a half, it achieved almost the max performance. After that, it goes into a refinement period where it tries to find an even better configuration. It was able to do so, but that takes a little bit more time. As a bonus, the tool also looks at configurations that may be invalid, right? So it builds kind of a knowledge base of that, which is great because then you know which combination of compiler flags, in this case, produce an invalid configuration, so you can avoid that. You have the ability to prune the flags that are not affecting performance, right? So you may have options that have no effect on the target metric that you're trying to optimize against. So it's going to not use those at all. That's also how it's able to converge really quickly on the optimal configuration. And so if I unpack the result, right, and kind of peel the onion here, one reason why that tool is so efficient, again, it goes back to the algorithm. This is based on an evolution algorithm that, to this date, no human was able to beat it. So we have yet to find an expert, a human, who manually was able to find a better configuration than what this tool was able to produce. That's one aspect. The other thing I want to point out is that, if you try to tackle this problem manually, you're basically trying to find a needle in a haystack because you're trying to find the one or maybe a handful of optimal configurations out of a number that's larger than the number of atoms in the known universe, just to put things into perspective. So it's a very difficult, impossible task to do manually. And that's why you must use automation and smart automation. One aspect unique to this tool is that it comes with an interactive user interface. And so, getting those results is one thing, but being able to analyze them and share them with colleagues and do that post-experiment analysis, really drilling down through the data is very important. And that's what's achieved through a really good user interface. And speaking of the data, there's a couple of steps that we see performance engineers want to do, after they run an experiment. Number one, you want to refine your experiment. Let's say you found a good configuration, but you end up with 150 flags that you need to modify every time. That's not ideal. Now, what this tool helps you do, Optimizer would go in and rerun the experiment, now trying to minimize the number of parameters that would need to be changed to achieve the same or similar level of performance. So you may go from 100 parameters down to less than a dozen, right? And still achieve the same level of performance. So there's a feature in this software that allows you to do that. There's also the sensitivity analysis, essentially trying to understand what's the impact of a given parameter on the overall performance, right? So you may want, this is more for engineers who are trying to understand the impact of one or a handful of parameters, really drilling down into the data and trying to see what's the effect of those specific parameters on the overall performance. And that's the idea behind this software, right? It's really trying to empower performance engineers. It's really helping them being much more productive in the way that they approach the problem and how they can get to a good answer, a good configuration. And at the tail end of that, the tool also provides a way to easily document and share the results of the experiment with the rest of the team. So we see that's a huge productivity gain for engineering teams.
That makes sense. Now, Nozar, I think we've come close to the end. Can you recap your main points for me?
Of course. So if I were to, summarize in 3 points, number one would be that benchmark tuning is not easy, but it's a step that's critical and necessary in order to obtain the maximum performance out of a given system. And one thing that's clear, and hopefully you've seen it throughout this presentation, is that doing this type of work manually is just not viable. It's highly inefficient. And at the end of the day, you don't know if the configuration that you have is the very best that you could obtain. Are you leaving performance on the table? And that's a question that's extremely difficult, almost impossible to answer if you're using a manual methodology. And finally, I want to really emphasize that, at the end of the day, smart automation is really the way to do it. As hopefully I was able to show you today, having a software that automates that whole process and really empowers engineers to focus on the analysis portion and quickly get to the results and good results without the time and cost burden is really key to success.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Nozar.
Thank you.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Synopsys. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talks section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.